In this video, we're going to talk about electrons, ions, and how atoms get charges, like +2 or -2. This video is especially for people who are preparing to take the TEAS exam, and it's part of my short course on the chemistry section of the TEAS. You can find a link to the full course in the description below the video. So, let's get started. Before we talk about electrons and ions, we have to review a few things about basic atomic structure. Remember that neutrons and protons both live in the nucleus in the center of the atom. Electrons are found in shells outside the nucleus. Now, neutrons are neutral. They don't have a charge, but protons have a +1 charge, and electrons have a -1 charge. Now, we're going to talk about neutrons in a different video, so we're not going to worry about them here. Instead, we're just going to focus on protons and electrons. For this whole lesson, we're going to focus on the charges of protons and electrons and see how they can balance out or cancel out. Here's what I mean. A proton has a +1 charge and an electron has a -1 charge, okay? So these are opposites and they cancel each other out. +1 and -1 equal 0. This 0 is what we call the net charge. It's like the total charge. And when you have the same number of protons and electrons like we do here, their charges balance out, or they cancel out, leaving you with 0 net charge. 0 net charge is another way to say electrically neutral. It doesn't have a charge. Let's look at some examples of this. Here is a carbon atom. We know from the periodic table that carbon is atomic number 6. That means it has 6 protons. Remember, atomic number is the number of protons that an element has in its nucleus. Now, unless we're told otherwise, we assume that every atom is electrically neutral, that it has 0 net charge. So we assume here that carbon has 0 net charge. And if this carbon atom has 6 protons, how many electrons does it need to have? Well, it has to have 6 electrons. 6 positive protons and 6 negative electrons cancel out fully, leaving you with 0 net charge. See how that works? Let's try a different atom. Here is a model of the nitrogen atom. Nitrogen is atomic number 7, so it has 7 protons in its nucleus. Again, unless we're told otherwise, we assume that the atom is neutral and has 0 net charge. So it's got 7 protons. How many electrons is it going to have? Well, it's going to have 7. 7 and 7 balance out for 0 net charge. Now, using what we've just learned, you're already ready for some TEAS questions. Let's try this one. How many electrons are in a neutral chromium atom? The first thing we do is we look at the atomic number. Chromium has atomic number 24, and that means that it has 24 protons in its nucleus. Now, the problem said that the chromium atom is neutral, so it has no charge. If it has 24 positive protons in the nucleus, how many negative electrons does it need to cancel these out for a 0 net charge? 24 negative electrons to cancel out the 24 positive protons, and 24 electrons is choice B. Now, you might have done this in your head. It wasn't very difficult, but things are going to get a little bit more complicated soon, so as we move forward, it won't hurt to write everything down kind of like this. Now, I'm not a mind reader, but I bet I know what you're thinking right now, okay? You're thinking, is it really that easy? The number of electrons always equals a number of protons, which is the same as the atomic number, right? It's not exactly rocket science. Well, that's exactly what we saw here in this example, but it's not always true. This is only true for neutral atoms with a net charge of 0. And not all atoms are neutral. Let me show you what I mean. Here we have a nice neutral atom. 4 electrons, 4 protons, 0 net charge. But the thing is, the number of electrons in an atom can easily change, and it changes all the time. For example, an atom can gain extra electrons. Let's imagine this atom here gets 1 more electron, and so now it has 5. You might wonder where that electron comes from. Don't worry about that for now. We'll talk about that in a future lesson. Anyway, the atom gains 1 electron, and now it has 5. But what about the protons? Well, an important thing to know is the number of protons in an atom doesn't usually change. So this atom is still going to have the 4 protons that it had before. The protons and electrons in this example are not equal anymore. So they don't fully balance each other out, and now we've got an atom that is not neutral, with a net charge that is not 0 because it gained an electron. And atoms can also lose 1 or more electrons. Where do they go? Don't worry about it right now. But if we lost 1 electron here, we'd have 3 electrons, 4 to 3, but we'd still have 4 protons because the protons aren't going anywhere. And we'd have another situation where protons and electrons don't balance out, where they're not equal, and so the atom is not neutral and has a charge. So the number of protons and electrons are the same only for neutral atoms. But when atoms gain and lose electrons, which they do all the time, the number of protons stays the same, and this causes situations where the atom is not neutral and it has a net charge. Let's look more closely at these two situations where the protons and electrons aren't equal, the charges aren't 0 here. But what are they? Well, remember that electrons are negative and protons are positive. Here we have 1 more negatively charged electron. We have 1 negatively charged electron that isn't getting balanced out by the protons, right? All of these are being balanced out equally, but we have 1 extra negative charge that's not getting balanced out. So the net charge, the total charge of this atom is -1 from this 1 extra electron. Over here, we have 1 more proton that isn't getting balanced out. Protons have a positive charge, so we have 1 extra positive charge, giving us a +1 net charge. Okay? So let's see how this kind of thinking works for some actual atoms. We'll take a look at lithium. Here's a diagram of it, and you might notice this diagram looks a little bit different than the others we've seen. The thing is, the TEAS exam and prep materials you'll see use many different types of atom diagrams. And it's important to understand the basics of the model, but don't get hung up on any one style. They'll all look a little bit different, but they'll all have the same basic parts: protons and neutrons in the nucleus, and electrons in the surrounding shells. So lithium is atomic number 3, so it has 3 protons here in the nucleus. And if the lithium atom is neutral, it's got to balance out these 3 positive protons with 1, 2, 3 negatively charged electrons. Now, for reasons that we'll explain in another video, lithium likes to lose its outermost electron here. You might remember from a previous video that this outermost electron is called a valence electron. And that's an important term, so we'll start using it here. The lithium atom likes to lose its valence electron. Boop, there it goes. And we're left with 2 electrons. So now we have a situation where we have an extra proton that isn't getting balanced out, and protons are positive, so that 1 extra proton is going to give this atom a net charge of +1. We have a special name for an atom with an electrical charge like this, with a +1. We call it an ion. An ion is an atom that has lost or gained electrons and so has an electric charge that's not 0. Okay, so this is a lithium ion, +1 net charge. And we can show that it has a net charge by putting a little positive sign up here, right? Li+. This plus sign means a +1 charge. We don't need to write the number 1. We can just put a plus sign. It's understood. So Li+ is a lithium ion with a +1 net charge. Furthermore, there's a special name for a positive ion. We call it a cation. Here's one silly way to remember this. Think that cats have paws, right? And a cation is positive. So, positive cation. Now, let's look at what happens in the opposite situation when an atom gains an electron. Here we have a model of a chlorine atom. If we look at the periodic table, we see that it has an atomic number of 17. So, neutral chlorine has 17 protons, 17 electrons. But here's the thing. Chlorine doesn't like being neutral. Chlorine likes to gain an electron. So let's give it one right here. There it is. And what charge is it going to have if it gains an electron? Well, now it's going to have 18 electrons, 17 protons, 1 electron that isn't getting balanced out. Electrons have a negative charge, so a net charge of -1. Okay? Here we have a chlorine ion. An ion is something that has a charge. And we can show this charge by putting a little minus sign up there. As before, we don't need to write the number 1. If you see just one minus sign, it means a -1 charge. So, chlorine ion, Cl-. Now, the positive ion is called a cation. There's a special name for a negative ion. A negatively charged ion is called an anion. Now, there's no cute kitten way to remember this one, but I like to think that the letters A and N here stand for A negative ion. So anion, A negative ion. That's another good way that you can remember this type of ion. Cats have paws, anion, A negative ion. So we have a chlorine anion, and we can say that there's something else to remember here. Unlike positive cations, anions get renamed. You can recognize an anion, a negatively charged ion, because it ends in the letters I, D, E. So the chlorine atom becomes the chloride ion, or you can just call it chloride. Now, the TEAS isn't going to test you on naming ions. You're not going to have to know that chlorine goes to chloride. I want to call things the right name, so I'm going to call this chloride, and also I want to let you know that if you see something on the TEAS that ends in IDE, you'll know it's a negatively charged ion, it's an anion. Okay, everything we just covered, let's use it to solve a TEAS question. How many electrons are in an F1- ion, or F- ion? That one negative sign means F1-. Before we look at the answers, let's do a little bit of atomic accounting, kind of add up our protons and electrons. Always look at the atomic number first. Fluorine has an atomic number of 9, which means it has 9 protons. Fluorine will always have 9 protons. Now, this isn't a neutral atom of fluorine, it's a F- fluoride ion, which has a -1 charge. So, if a fluoride ion has 9 protons, we know that it has 9 protons because of the periodic table, how many electrons does it need for a -1 charge? Remember, electrons are negative, so it has to have 10 electrons. That's 9 electrons to balance out the protons, and then one more negatively charged electron to bring the charge to -1. So it's going to have a total of 10 electrons, D. But look at the other choices here. They're being sneaky. Choice A makes it look like fluorine only has 1 electron. You might see that -1 and be tempted to pick this. And choice B would be right if fluorine had lost an electron, okay? But then it would have a +1 charge instead of a -1 charge. Remember, electrons are negative. And of course, C is a neutral atom. 9 electrons, 9 protons. So you see, the TEAS always plans for common mistakes. It can figure out what you are likely to get wrong, and that's why it's really important to know this stuff super well. If you just kind of have a basic familiarity on this, but you're kind of shaky, well, the TEAS is going to know exactly how to trick you with these kind of answer choices. So it's also helpful to go through this type of atomic accounting where we kind of add everything up and just make sure that we're not getting confused. Work through the math, and that's a good way to be confident in your final answer. Okay, so far we've only seen examples of atoms gaining or losing a single electron. But atoms can gain or lose more than 1 electron. So let's look at some examples of that. For instance, magnesium likes to lose 2 electrons. So what would its charge be, and what would its balance of protons and electrons be in this situation? Well, we'll do some basic atomic accounting. We know that magnesium has 12 protons because that's its atomic number. So if it loses 2 electrons, it will only have 10 electrons left, and it will get a +2 charge, right? It has 2 more protons than electrons, and protons are positive. So the magnesium ion is Mg2+, and it is a cation. It's a positive ion. Now, notice a few things about the symbol. First of all, we don't use just a plus sign. We write 2+, and it's not like 2 plus signs, it's 2+, Mg2+. Now, let's look at oxygen. Oxygen likes to gain 2 electrons. So what charge is it going to have? Well, we know that it has 8 protons because that's its atomic number. And if it gained 2 more electrons, it would have 10 electrons. What's the charge going to be? Well, now it has 2 electrons that aren't getting balanced out by the protons. Electrons are negative, so it's going to have a -2 charge. The way we're going to write this is O2-. Remember, a negatively charged ion is known as an anion, so we can call it an anion. And here's another thing, we see a name change. We go from oxygen to oxide. Don't worry about that too much. You wouldn't be able to predict it, but remember that the IDE ending means it's a negatively charged ion. Before we move on, I want to discuss one common mistake. When people do problems like this, they sometimes forget that electrons have a negative charge. So, when an atom like magnesium loses electrons, it becomes more positive. Because when you get rid of negative electrons, you become more positive. And the same goes over here for negative anions. Oxygen has gained 2 electrons. That means it has 2 more electrons and protons, so it becomes more negative. You add negative electrons, you become more negative. So the TEAS knows that people make these mistakes, so they always try to trick you. One more thing to mention, and then we'll try some TEAS problems. When we said that the oxygen atom becomes the oxide anion, you might have thought, what the heck? Why isn't it oxygenide? What about oxyide? The fact is, unless you memorize the names of all the anions, it's hard to guess the right name. But don't worry about this. Just like we said earlier, I want to use the right names for things, but the TEAS won't ask you to name ions. It will just ask you to recognize them. So you see that IDE, it means that it's an anion with a negative charge. Don't worry about coming up with a name on your own. So let's use everything that we've learned to work through some TEAS questions. Aluminum is atomic number 13 on the periodic table. How many electrons are in an Al3+ cation? Ready? The question wants to know how many electrons this ion of aluminum has. To find that, we need to first know how many protons it has. So we look at the atomic number 13. That means it has 13 protons. That can't change. Aluminum always has 13 protons. So how many electrons does it have? Well, we know that it has 13 protons. If it were neutral, it would have 13 electrons. But it has a +3 charge, so it needs to have 3 positive protons that are not balanced out by electrons. So it'll have 10 electrons, 13 protons for a +3 charge, and that is choice B. There are a few things to point out here. A might be tempting because of the 3, and we're talking about a 3+ charge, but that's just there to trick you. Choice C is 13 electrons, which would be a neutral atom. And finally, look at that. The TEAS is expecting that some people are going to confuse the charge of electrons and that you might choose 16, which would give it a charge of 3- because it would be 3 more negative charges. So just remember, the TEAS knows all the common mistakes, so you want to make sure you understand this material very, very well. Since this is so challenging, let's try one more problem, okay? An atom of sulfur gains 2 electrons. Which statement describes the resulting ion? Let's start by doing a little atomic accounting, then we'll pick the right answer. As usual, we'll use the atomic number to determine how many protons sulfur has. Its atomic number is 16, so it's got 16 protons. That's not going to change. Normally, a neutral sulfur atom would have 16 electrons to balance out the 16 protons. But this problem says that sulfur gains 2 electrons. So let's do a little accounting and think through the math. 16 protons and 18 negative electrons. That's 2 more electrons that aren't getting balanced out by protons. Electrons have a negative charge, so we're going to have a -2 charge. All right, now we look over our answers, and you'll see that both B and D have the correct charge, S2-. But which of these is correct? Well, look at the difference. Choice B calls this a cation, but that's a positive ion. So it's not choice B. We can get rid of that because this is a negative ion, and the correct name for a negative ion is an anion. So choice D is the correct answer. We have the right ionic charge and we have the right name of anion. Now, you might not have known that the name was sulfide as opposed to sulfuride or whatever, but you didn't really need to know that. You just do your accounting and know the difference between cations and anions. So that's it for electrons and ions. In our next lesson, we'll talk about neutrons and isotopes. See you there.